All right. Why? So here we need to eliminate the parameter and sketch the curve. So if x is equal to the square root of t, square both sides. T is equal to x squared. Y is equal to 2t minus 1. Plug in t is equal to x squared, and y is equal to 2x squared minus 1. And if y is equal to 2x squared minus 1, we can rewrite this as y is equal to 2 times x minus 0 squared minus 1. And as we rewrite in this form, we see that the vertex is going to be at hk, where h is 0 and k is negative 1. So a vertex at 0, negative 1. Right here, a vertex is 0 and negative 1. And let's plot some other points. When x is 1, 1 squared is 1, 2 times 1 is 2, 2 minus 1 is 1, so we're at 1, 1. Negative 1, same thing, negative 1 squared is 1, 1 times 2 is 2, 2 minus 1 is 1, so negative 1, 1. 2 squared is 4, 4 minus 1 is, well, 2 squared is 4, 4 times 2 is 8, 8 minus 1 is 7, so we're at 2, 7. Same thing, we're at negative 2, 7. So we have a parabola, and at this point we are off the charts. This is our parabola. This is our curve, and we sketched. Now we need to sketch the curve, the plane on the curve pi. T is in between pi and 2 pi. And so we need to square each term, isolate our trig parts, add both equations, and use sine squared of theta plus cosine squared of theta is equal to 1, and then sketch the domain. So let's square each term. So x is equal to 6 cosine of t, y is equal to 4 times the sine of t. And so what we can do here is we can square each term. All right? So with your calculator, try to square each term. So if x is equal to 6 times the cosine of t, then if we square each term, x squared should be equal to 36 times the cosine squared of t. And if y is equal to 4 times the sine of t, then y squared should be equal to 16 times the sine squared of t. All right, so you need to square each term. Step 2 is to isolate the trig parts. So x squared is equal to 36 cosine squared of t. X squared is equal to 36 times the cosine squared of t. Y squared is equal to 16 times the sine squared of t, which means x squared over 36 is equal to the cosine squared of t. And y squared over 16 is equal to the sine squared of t. So we can write add this up, and so we can say we know the trig identity. So this goes back to your trig identity. The sine squared of t plus the cosine squared of t is equal to 1. So sine squared of t plus the cosine squared of t is equal to 1, which means that if this is equal to cosine squared of t and this is equal to sine squared of t, we should say that the x squared over 36, which is equal to the cosine squared of t, plus the y squared over 16 is equal to 1, in the same way that the cosine squared of t plus the sine squared of t is equal to 1. These cosine is going to match up with x squared over 36. The sine is going to match up with y squared over 16. And it's all equal to 1. X squared over 36, y squared over 16. So you have 0, 0, 36 over 16. And this becomes an ellipse, right? So sketching this curve, we will have, let's see, this is an ellipse with a center So the ellipse, the center is 0, 0. The ellipse is horizontal. All right, and for a major axis, so 36 is equal to, if our center is 0, 0, 36 is equal to a squared, which means a is equal to 6, and 16 is equal to b squared, so b is equal to 4. So which means we're going to have vertices at -6 and 6, and then we'll have a co-vertice at -4 and 4. And if we are in between pi and 2 pi, remember for radians, this is going to be 0/2 pi, pi over 2, pi, and 3 pi over 2. So if we are only in between pi and 2 pi, we're only going to be on this part of the graph. So essentially, this says we are on the bottom half of the graph. So we could draw the full ellipse. So this is the full ellipse. But as far as the parametric equation goes, this is the only thing that we would have to show. And showing the movement of time, we would start at pi and move towards 2 pi. This is good. This involves a lot of conversions here. So that was example 5. Let's do example 6. Okay. We need to find the parametric equations from the given conditions. A parabola with a vertex 2, -3 opens downward. We have to know that y is equal to a times x minus h squared plus k. All right. So we know that. I have to know that substitute with the given information because it opens downward. Y is equal to, has to open downward, so this has to be at least be -1, has to be negative number, times x minus 2 squared plus negative 3, so minus 3. So we can say A is equal to negative 1, H is equal to 2, and K is equal to negative 3. All right. Add time as a third variable. So we can let's say let X is equal to T. And so now we have our equations. All right. If X is equal to T, then Y is going to be equal to negative T minus 2. Oh, sorry, this is a parabola, so it's squared. T minus 2 squared minus 3. All right. So when we sketch, we're going to sketch when T is greater than 0 in blue, and when T is less than 0 in red. All right. So when T is greater than 0, we have let's plot things out. We have when T is greater than or equal to 0. So let's do when T is equal to 0. T is equal to 0 when X is equal to T, so when T is 0, X is 0. Then we have negative 0 minus 2 squared, so negative 2 squared, which is going to be 4 times negative is negative 4 minus 3. So that's going to be negative 7. All right. 1 minus 2 squared is going to be 1 times negative 1 is negative 1. Negative 1 minus 3 is going to be negative 4. Of 1, negative 4. 2 is just going to be negative 3. And then you would have 3, negative 4, 4, negative 7. But additionally, we have to say that this would be the parabola in blue. But anytime past blue, parabola would be in red as it moved downward in this direction, and would be blue as it moved downward in that direction. Okay, so that is our variable, and we're good to go.